Our next speaker will provide us with more insights into telecommunication and its evolution from 1G to 5G. She's a recognized Finnish specialist who holds a PhD in intelligent systems and master degrees in applied mathematics and in computer science. She's a technical team lead in 5G baseband processing development for Nokia product. Her contribution to Nokia has been recognized, and she became a Bell Labs Distinguished Member of Technical Staff for technical excellence and outstanding contribution. Today, with a presentation on telecommunication from 1G to 5G, joining us from Oulu, Finland, let's welcome Olga Kayo.
Thank you very much. Good afternoon. Thank you to the organizers of the conference for the opportunity to be a speaker in this important event. Today, we will have a short trip to the history of telecommunication. The goal of this presentation is to show that technology has its own roots and it has been developed in the centuries by human beings. The order is very important for the base of technology development. First, there was a need of humanity to communicate over the distance, and then there was a solution to satisfy the need. Every day in 21st century, billions of people around the globe interact with one another and communicate through devices that rely on telecommunications to transmit and receive messages, voice calls. Smartphones, tablets, the internet, servers, networks, laptops, and landlines, phones all operate on telecommunications backbone. People hear the term telecommunications all the time, but how many of people truly understand what telecommunication means? The definition of telecommunications is hidden in the word itself. There are two roots. Tele, the first root, is coming from Greek language, and its meaning is to or at distance, and the word communicatio coming from Latin. This means the social process of information exchange. Combining tele and communicatio, we are getting telecommunication, which means the process of information exchange over the distance. It is natural for human beings to talk, to communicate. It is one of the basic needs of human in addition to sleep and getting meal and water. Let's consider how people communicate over distance. When two persons are at the same room, they are talking. When one person is going to yard, then there is a need to shout to be able to support the communication. When there are kilometers between two persons, the message is sent with messenger. People were thinking all the time on how to speed up the delivery of the message, to inform other side about urgent issue, to warn. Let's now start from the history. Of course, nowadays, when we would like to warn someone about something, we just take a phone call and call. But very first generation of telecommunication is based on different technology. It's completely based on visual signal transmission. It has been known quite a long time ago. 20th century BC used torch signals to communicate message. Then it evolved to hydraulic telegraph in the 4th century BC to transmit predefined messages. And then it also was possible to use with coded fire signals later on. In my speech, I'm going now to cover hydraulic telegraph system. Here you can see the image which we have nowadays about that system. In order to transmit a message from point A to point B, there is a need to have two similar in volume vessels which were filled with water. Inside of that vessel, there was a floating message indicator stick. Here you can see a message indicator stick coming out of the vessel and the vessel itself. On the other side, it is shown somewhere here, beyond on this big hill, there was another device with a similar in volume message and with a similar in volume vessel and with message stick. When message needs to be transmitted, the soldier on transmitter side raised a torch showing that the signal is ready to be transmitted. On the receiver side, the other soldier raised a torch showing that they are ready to receive the message. Then at transmitter side, the torch was hidden, showing that the transmission started. And the soldier at transmitter and receiver side simultaneously opened the taps. The level of the water in the vessels goes down. When the needed message is on the needed level, then the soldier at transmitter side raised a torch, showing that now message has been transmitted. The soldier at receiver side closed the tap and message received. So it is clear that with such kind of transmission, we have a lot of limitations. For example, if it is cloudy, we will not be able to see the other torch. But in best conditions, it was possible to transmit around 50 letters per minute over distance 2 kilometers. If we translate this into kilobits, it is about 0.4 kilobits per minute. Let's now calculate how many minutes do we need to download one movie from the internet with such speed. Of course, all of us now watching movies, and on average, one movie takes around 90 minutes. So 90 minutes time, which is 1 gigabyte of data. So by using simple calculation, division of movie size into the bit rate, we are getting 21.5 minutes for transmission of that movie. Okay, by simplifying it, we can now claim that with such a speed, one movie would be transmitted over 40 years. During 40 years, quite a long time, especially if you take into account that distance for that transmission is only 2 kilometers. Of course, there were different kinds of devices introduced later on. And all of them were based on the transmission by using this visual-based technology. The technology significantly changed in 1837. So I put it as 0.5G. So that was possible because of discovery of electricity by Hans Christian Oertzen in 1820 and electrical batteries, which were discovered by Alessandro Volta in 1824. Based on these inventions, Samuel Morse and Joseph Henry Alfred Vail developed a simple, short code for transmission across telegraph lines, enabling messages to be sent across country with a speed which has never before seen. How the message transmission was done? With electrical pulses, the silence also was used between these pulses. Specific letters were sent. So Morse developed the alphabet. Here you can see 3 letters presented by Morse alphabet. And these letters were sent to transmit the message. first, during the discovery of this technology, the message was transmitted on the length of the wires lines, but later on, it was wireless. It became wireless in 1895, and the distance between point A and B was from 5 to 48 kilometers. Now when we take a look at the average speed in this kind of transmission reception, it is about 50 words per minute. So which is about 0.7 kilobits per second. So when we calculate how long would it take for one message to transmit, or for one movie to transmit with this speed, it would take 20 years and 5 months. So with this technology, we have clearly improvement, almost half in time for transmission of one movie. But still it's quite long, right? So let's see what happened with the next generation. So here you can see this Morse transmitter example. The next generation is 1G. It is so-called analog cellular networks, and it has appeared in 1979. Of course, the phones were portable already at that time, but the size of the phones were quite big, and weight was up to several kilograms per one phone. So, and why it is analog? Because voice was transmitted as an analog system. The only operation was applied to the voice is modulation to higher frequency. So, on average, a voice of adult male has frequency from 85 to 180 Hertz, and voice of adult female has from 165 to 255 Hertz. So the modulation was amplifying the frequency to 150 megahertz, meaning that amplification went up to 10,000 times compared to the range what human ear can accept. And with that system, of course, data rate has increased a lot, and we could transmit already movie within 40.5 days, one gigabyte movie. Technology didn't stay at that time, and it starts its evolution to 2G. Approximately after 10 years, this GSM, Global System for Mobile Communication, 2G technology appeared on the market. The first mobile call on GSM network was done in Finland in 1991. So what was new in the GSM network that user could see immediately? So first of all, text messages became possible, and prices for mobile phones dropped significantly. Why? Because now it was not analog, it became digital. So, and it became cheaper, it became faster, and radius of coverage of network became wider. So number of users grow. So then when we calculate what would be the time for transmitting 1 gigabyte data over that network, you can see that improvement is clearly visible, and it's now around 2.5 days. But of course, there was also, after maybe 5 years after 2G was discovered, there was evolution of that network to 2.5G generation, the data rate was increased even further. So the highest data rate was achieved 500 kilobit per second. And then with that speed, our movie would be downloaded within 4.6 hours. Then after 10 years, there was a 3G, third generation network launched on the market. So as you notice that between every generation, there are 10 years approximately time. So now you can tell when 6G network will come. So the first 3G network appeared in Japan. In the same way as 2G, 3G network is completely digital. And all the following networks are digital. What is new in 3G compared to the previous generations? It's very important to see that now 3G network can support circuit switching and packet switching. So let's take a look what does circuit switching and packet switching mean. Circuit switching guarantees a more reliable connection because when we have a transmission circuit switching starting, we are opening channel which stays open until message is transmitted. So in the same way, when we use a landline phone, when we call to someone on the other side, so no one can call to us back because line is busy. And even so that we are not speaking, no data is transmitted actually over the lines, the line stays open, connected. So of course, with circuit switching, the data transmission is not optimum. Why? Because we cannot use all the resources of the network optimally. Packet switching forms packages from the data and transmit package every time when there is when there are resources available in the network. So of course, then with packet switching, it is possible to support more users in the same network, and that also simplifies support simultaneously of data and voice transmission. So in 3G, circuit switching was using for voice calls and packet switching was using for data transmission. So data transmission here we mean SMS, then it was possible also to have MMS, and then some of the 3G models of mobile phones was supporting the video calls and some streaming. The data rate increased dramatically to be able to support this video streaming. So, and now 1 gigabyte movie transmission is done within 1 hour and 8 minutes. Okay, quite impressive change. Now, after 10 years, can you guess what happened? Yes, 4G network came into life. So-called long-term evolution, and its evolution, LTE Advanced, appeared 3 years later. Starting from 4G, only packet switching supported, meaning that voice is also transmitted over the packages. That's amazing innovation, which allows to support more and more users with the same subcell, with the same mobile station. Moreover, this new method started to use so-called technology MIMO. Many of you have heard it. Multiple input, multiple outputs. It helped to attain ultra-high spectral efficiency by using multiple transmission and receiving antennas. So to transmit signal, we have dedicated spectral allocated for it. Of course, we can transmit it by using one antenna, one transmit antenna and receive by using one receive antennas. But when we use multiple antennas, we can use mathematics to be able to transmit more data within the same spectral allocation. So with this kind of improvements, now it is possible to download movie, 90 minutes movie, 1 GB data within 1 minute 22 seconds. So for 5G, of course, we are getting even further improvement. 5G combines all possible improvements from all the technologies and put it into one. You can see that it is possible to download the data even less than within 1 second. In 2019, 2020, this technology is still being introduced. Here is the so-called Nokia 5G Nokia triangle to show where these kind of speeds can be used. Of course, they can be used in augmented reality when we have to have very high data rate and ultra latency. It would be possible to support distance surgery when doctor is located in one city and patient is in the other city. With massive machine communication, we can support multiple vending machines and householding machines attached to the internet. And with unlimited experience, we can keep all our data not at our devices, but in the cloud to keep photos and movies and everywhere and everything what we don't need to be in our phone and our drives, because this is going to be very, very quickly accessible at any time we need. So let's see what would be the graph showing the improvements between 0G and 5G. Here you can see the amount of data, the amount of time in terms of hours for downloading 1 GB movie. So let's consider 3G, 4G, 5G in more details. Okay, it still needs some hours, but when we move to 4G and 5G, you can see that improvement in seconds. It's very dramatical. So also and 5G is not the final data transmission technology. Now, they've already 4 years when 6G have been developed in universities, and the first trials were done in Japan. So, and with this needs for specialists growing extremely fast, so you can actually make the difference and come to technology and help the developing of the future technology as mathematician, programmer, engineer, or project manager. We also need leaders to lead all these programs. So if you are interested to come and introduce your view into the technology, please do so. It's very vital to society to stay connected in all the times. During this presentation, I tried to introduce you telecommunications past, and I hope that some of you would be considering building a career in the tech. Thank you.
Olga, this is impressive how the technology is changing throughout the years. Thank you for showing us that. Once again, thank you for speaking to us.